Sometimes on your way home from school, you might want to take a different route. Maybe then you can stop by the mall to spend your pocket money. Or maybe you'll find a new stall selling some delicious French fries. A little variety often makes things more fun, right? We like that in maths as well. So, let's switch things up. Remember how we wrote complex numbers in terms of x and y? This algebraic form can be converted to ordered pairs. All we need is to write the real component on the left and imaginary component without iota on the right, separated by a comma. While they represent a complex number, both x and y are real numbers themselves. This creates a new set, R cross R, known as set C, complex numbers. We will talk about that later in detail. But first, some basic laws applicable to this set. So, let's start with the first one. If two ordered pairs are equal, then their x and y coordinates equal each other. Does this remind you of something? Yes, the first law for complex numbers. In fact, you will notice similarities to previous laws as we continue. See how many you can point out. Now, let's turn to addition. When you want the sum of two pairs, just add the x and y coordinates to each other and subtract them for the difference. Once again, does this remind you of older laws? Yes. What about multiplying a constant? Given a real number k, just multiply it separately to each coordinate. You could also multiply two ordered pairs together, but this gets a little complicated. Don't worry though. Do you remember the product of two complex numbers? It always came in standard form, so we could skip all the long steps in between. Well, it's the same format for ordered pairs. Just replace the plus sign with the comma and enclose everything in one single bracket. That's all. Now, let's test out this new information with examples. We need to find the sum, difference and product of these two ordered pairs. First, figure out which coordinates are x and y. Then add them for the sum and subtract for the difference. But what about the product? Simply bring our handy product formula to the spotlight. Compare it with the given values and note the coordinate in terms of the letters. Then plug them here. If the decimal point confused you, don't worry, that's just another symbol for multiplication. For our ease, do this simple math and you have your product. Moving on, do you recall the mathematical laws of real numbers? Yes, some of them apply here too. More specifically to set C. Like the additive identity, we want the same ordered pair back. So we add it to 0, 0, which is the additive identity. Well, how about the additive inverse? It's the same pair but the signs flipped. So, their sum is 0, 0. Up next, the multiplicative identity. It's 1, 0, because that gets us the same coordinates back after multiplication. Use the product formula and obtain this long expression. And you will find that it comes down to just a, b. And finally, the multiplicative inverse. Any ordered pair that's not 0, 0 has a multiplicative inverse. It looks long, but if you multiply, you get 1, 0, the identity element. Test this out on your own using the product formula. We believe in you. Lastly, how do you multiply an ordered pair with the sum of two others? It looks a little crazy, but hang on. The rule is to multiply the pair outside the bracket by the brackets inside first. Then, you can multiply them together and add once more. And that, my friends, closes out the laws. We won't cover the properties of inequalities because it doesn't make sense to say one complex number is larger or smaller than the other. But in our next lesson, we'll look at a special subset of C. More variety, which is great for us.